Good morning everybody. Today is fourth lecture on Newton-Raphson method of load flow. On last turn, we have discussed Newton-Raphson method of load flow for PQ buses. Today, we will discuss the case when both type of buses are there, PQ buses and PV buses. Recall, we have del P, del Q is equal to Jacobian matrix J11, J12, J21, J22, del delta, del V. So left hand side quantities are corresponding to specified quantities, and this right hand side quantities del delta del V are corresponding to unknowns. So today we are including PV buses also. So for PV buses, remember two things. One, P is specified but Q is not specified. Q is not specified, so corresponding to PV buses, del Q will not appear on LHS. So right here, this implies del Q for PV buses, we are talking about for PV buses, del Q will not appear on left hand side. Similarly, second, we can write here for PV buses, V is specified. V is specified. So V is not unknown for PV buses. Therefore, right hand side del V will not appear for PV buses. You can write del V will not appear on right hand side. Right hand side quantities are corresponding to unknowns. So for PQ buses, both delta and V are unknown, hence will appear. But for PV buses, V is specified. So on right hand side, del V will not appear, only del delta will appear. Consider a simple network having 5 buses. Let us draw it. Okay, say bus number 1 is slack bus, bus number 1, slack bus, and say this is bus number 2, say PQ bus, bus number 3, PV bus, bus number 4, PQ bus, and bus number 5, say PV bus. We have considered 5 bus system having all type of buses, PQ buses on bus number 2 and bus number 4, as well as PV buses at bus number 3 and at bus number 5. So first make a table here. Say first column bus number, second column known quantities, or we may write specified, and third column unknown quantities, not specified quantities, not specified. So apart from slack bus, we are having 4 buses, bus number 2, 3, 4, 5. Right here, bus number 2, 3, 4 and 5. So at bus number 2, this is PQ bus. So known quantities, that is specified quantities, are P2, Q2. Right here, P2 comma Q2. For bus number 3, it is PV bus. So P3 and V3 quantities are specified, P3 comma V3. So for bus number 4, PQ, hence P4 and Q4 are P4, Q4 are known quantities, that is specified quantities. Similarly for bus number 5, that is PV bus, P5 and V5. P5 and V5 are known. What about unknown quantities? At bus number 2, unknowns are P and Q are known quantities. So unknowns are V2 and delta 2. Delta 2, V2 are unknown. For bus number 3, it's a PV bus. So delta 3 and Q3 are unknown. For bus number 4, again PQ bus. So delta 4 and V4 are unknown. And for bus number 5, that is PV bus, so delta 5 and Q5 are unknown quantities. So we may write what is del P here? Corresponding to specified quantities. So del P will be corresponding to all PQ and PV buses both, because P is specified quantities for both PQ and PV. So from here we may write, so specified quantities P2, P3, P4, P5. So del P can be written as is equal to del P2, del P3, del P4 and del P5. What about del Q? So we may observe from here Q2 and Q4, only Q2 and Q4 corresponding to PQ buses only are specified. So right here del Q will be equal to del Q2, del Q4, del Q2, del Q4. What about del delta? So del delta corresponds to unknowns. So unknowns here, again delta is unknown for all buses, whether PQ or PV, for both. So we may write del delta 2, del delta 3, del delta 4, del delta 5. Okay, and what about del V? So del V again corresponding to unknowns. So V2 and V4 are unknown. For PV buses, V is known. So we will write del V, del V4. Corresponding to PQ buses. So we may write for PQ buses. Similarly, del Q will be corresponding to PV buses for PV buses. No, not this del Q. That del Q is for a specified quantity, so PQ buses. Because bus number 2 and 4 are PQ buses. For PQ buses, these are unknowns. So these are for all. We may write for PQ and PV buses. And similarly, del P also for both PQ and PV buses. So we have written del P, del Q, del delta and del V for the 5 bus network. Now next we will write J11, J12, J21 and J22. So J11 will be J11. Remember our numbering 1 and 2 from left side, 1, 2 from right side. So J11 means first from left side and first from right side. That will be del P, del delta. Observe del P, this one, and del delta, this one. So make the J11 matrix with the help of del P and del delta. So first row will be corresponding to del P2 and all delta. So write the first row of J11, that is corresponding to del P2. So we will write del P2 upon del delta 2, del P2 upon del delta 3, del P2 upon del delta 4 and del P2 upon del delta 5. Corresponding to all these. First row is completed. So write second del P3, see here P3 is here, upon del delta 2, del P3 upon del delta 3, del P3 upon del delta 4, del P3 upon del delta 5. Similarly, or we have two more, we can write it. So del P4 upon del delta 2, del P4 upon del delta 3, del P4 upon del delta 4, del B4 upon del delta 5. The last one, del P5 upon del delta 2, del P5 upon del delta 3, del P5 upon del delta 4, del P5 upon del delta 5. So what will be order? Order will be 1, 2, 3, 4. We can observe from here. The order of this is 4 by 1 and the order of this is also 4 by 1. So J11 will be of the order of 4 by 4. Clear? So next we may write J12. J12, first from left side, second from right side, that is del P, del V. So concentrate on del P and del V. So first row will be corresponding to P2 and V2, del V2, del V4. So write here J12 is equal to, first one will be del P2 upon del V2. We are having V2 and V4. So next will be del P2 upon del V4. That's it. Next is P3. So write second row of J12, del P3 upon del V2, del P3 upon del V4. The next one, del P4 upon del V2, del P4 upon del V4. The last one corresponding to P5, del P5 upon del V2, del P5 upon del V4. So order of this matrix J12 will be 4 by 2. Order of this matrix is 4 by 1, order of this matrix is 2 by 1. So the order of J12 will be 4 by 2. Clear? So next, using similar procedure, we can evaluate J21. So J21 will be 2 1, second from left Q and first from right delta, del Q and del delta. We have to focus on del Q and del delta. Obviously order of this is 2 by 1 and order of del delta is 4 by 1. So matrix constituted will be 2 by 4. So first row starts corresponding to Q2, del Q2 upon del delta 2, del Q2 upon del delta 3, del Q2 upon del delta 4, del Q2 upon del delta 5. The next row corresponding to Q4 only. So del Q4 upon del delta 2, del Q4 upon del delta 3, del Q4 upon del delta 4, del Q4 upon del delta 5. So the order will be 2 by 4 right here. So the matrix J21 is constituted and the order can be observed from here itself, 2 by 4 right here, 2 by 4. The last one, J22. For J22 we will take second from left and second from right. So that will be del Q, del V. See, del Q is 2 by 1 and del V is 2 by 1. So the order of J22 will be 2 by 2. So first row will be corresponding to Q2 and V2, V4. So right here J22 is equal to del Q2 upon del V2, it is V2. Next del Q2 del V4, del Q4 upon del V2 upon del V2 and del Q4 upon del V4. So order is 2 by 2. This way we can evaluate the elements of Jacobian matrices. So we can evaluate the elements of Jacobian matrix. So now we know how to construct this matrix del P, del Q, del delta, del V and all the elements of the Jacobian matrix. Now consider the generalized case. Assume we are having n bus system in which first few buses from 2 to say M are PQ buses and the remaining buses are PV buses. We will write here, consider n bus system, n bus system in which obviously first one is slack bus and say 2 to M are, we may write 2 to M are PQ buses and remaining buses say m plus 1 to n are PV buses. So first write del P. Del P we can write, del P will be equal to, remember P is specified for all the buses, whether PQ or PV. So del P will be for all these buses from 2 to n, right here, del P2, del P3, so on up to del Pm. Corresponding to all PQ buses we have written del P. Next, corresponding to PV buses, m plus 1 del P, m plus 2 and so on up to del Pn. So order will be n minus 1 cross 1, except slack bus, all buses are having P as a specified quantity, hence we will get del P. So this portion corresponds to PQ buses up to m, 2 to m. From m plus 1 to n corresponds to PV buses. Clear? Similarly, we will write del Q here. Write del Q here. So del Q, Q is specified only for PQ buses. So we will write from 2 to m, del Q2, del Q3 up to del Qm. Order will be m minus 1 cross 1, we may write for PQ buses. Next we will write del delta and del V. So del delta we may write here, del delta is equal to, again delta is unknown for all PQ and PV buses. So we may write del delta 2, del delta 3, del delta m, del delta m plus 1 and so on del delta n. So order will be again n minus 1 cross 1. Attention here, this portion again corresponds to unknowns for PQ buses. Same PQ buses, you may write PQ buses. And these quantities are corresponding to PV buses. Fine. The last one, del V. We will write del V here. Del V is equal to, so V is unknown only for PQ buses, and PQ buses are from bus number 2 to bus number m. So write here del V2, del V3, del Vm. From bus number 2 to bus number m, V are unknown, as we have assumed these buses as PQ buses. So order will be m minus 1 cross 1. This way we have del P, del Q, del delta, del V. The next task will be to evaluate the elements of Jacobian matrix. So first start again with J11, 1 1. So J11, 1 from here, 1 from here, del P, del delta. Del P is here, del delta is here. So order will be n minus 1 by n minus 1. Start first row, del P2 upon del delta 2, del directly write del P3 del Pm upon del delta. This will be del P2 del delta m. Take P2 first for first row and corresponding to delta 2, delta 3, delta m here. So next will be del delta m plus 1, del P2 upon del delta m plus 1 and so on up to del delta n, del P2 upon del delta n. First row is completed. So next will be corresponding to P3, again the same variables. So I am going to write for Pm. So del Pm upon del delta 2 and so on, del Pm upon del delta m, del Pm upon del delta m plus 1 and so on, del Pm upon del delta n up to delta n. So we have written the row corresponding to m plus 1, Pm plus 1. So next will be corresponding to Pm plus 2. So I am going to write the last one. The last one will be del Pn and is starting from delta 2 to delta n. Del Pn upon del delta 2, so on, del Pn upon del delta m. Okay, write this also, del Pn upon del delta m plus 1 and so on. The last one, del Pn upon del delta n. So order will be n minus 1 cross n minus 1. From here also we can observe starting from 2 m minus 1, again m plus 1, so n minus 1. From here itself 2, 3 m n, so n minus 1. We can write the order here n minus 1 cross n minus 1. This is n. Similarly, we will write J12. For J12, we will focus on 1, 2, del P and del V. Del P is here and del V is here. The order will be n minus 1 cross m minus 1. So first row will be constructed using del P2 and del V2, del V3, del Vm. So write the first row, del P2 upon del V2, del P2 upon del V3 and so on, del P2 upon del Vm. Similarly, the next row will be corresponding to P3. So directly I am going to write for del Pm, right here, del Pm, del V2, del Pm, del V3, del Pm, del Vm. And the next will be corresponding to del P m plus 1. So write the last one, last row corresponding to del Pn. Del Pn upon del V2, del Pn upon del V3, del Pn upon del Vm. Write the order n minus 1 cross m minus 1, n minus 1 cross m minus 1. We can write here itself. What is the order of del P? Order of del P is n minus 1, right here. order n minus 1 cross 1. What is the order of del q? The order of del q is m minus 1 cross 1. Right here, m minus 1 cross 1. What is order of del delta? Right here. So del delta, order of del delta is n minus 1 cross 1. What is order of del v? M minus 1 cross 1. 1. So what is order of J11? N minus 1, 1 from here, 1 from here, n minus 1. We can judge from that matrix also, J11. So order, we may write n minus 1 cross n minus 1 for this. What about J12? We have written here n minus 1 cross m minus 1, or from here itself. First from here n minus 1, second from here m minus 1. So order we may write n minus 1 cross m minus 1. What about order of J21? We will see later. So first write J21. So J21 may be written as is equal to 2 from left, second from left, q, and first from right, delta, q delta. Focus on del q and del delta, this. So order will be m minus 1 cross n minus 1, and first row will be constituted corresponding to q2 and delta 2 to delta n. So write first row del q2 upon del delta 2, del q2 upon del delta m. Next will be del q2 upon del delta m plus 1, del q2 upon del delta n corresponding to this. First row is constructed. The second row will be corresponding to del q3 right here, del q3 upon del delta 2, del q3 upon del delta m, del q3 upon del delta m plus 1, and so on, del q3 upon del delta n. The last row corresponding to qm. So this will be del qm upon del delta 2, del qm upon del delta m, del qm upon del delta m plus 1, del qm upon del delta n. Write the order here, m minus 1 cross n minus 1, m minus 1 cross n minus 1. We may write here itself. The order will be m minus 1 cross n minus 1, and from here itself we can write 2 1, second m minus 1, and first one from here n minus 1. So order will be m minus 1 cross n minus 1. The last one, for this generalized case, we may write the fourth Jacobian element J22 as this will be equal to second from left, second from right, del q, del v. So del q is here, del v is here. The order will be m minus 1 cross m minus 1, and the first row will start with q2. So del q2 upon del v2. Next will be del q2 upon del v3, del q2 upon del vm. Understand? Write the next row. Next row will be corresponding to q3. So it will be del q3, del v2, del q3 upon del v3, del Q3 upon del Vm, and the last row will be del Qm, del Qm upon del V2, starting from V2, then V3 and so on. Del Qm upon del V3, del Qm upon del Vm. So the order will be m minus 1 cross m minus 1, right here m minus 1 cross m minus 1. The same order will be written here for J22, m minus 1 cross m minus 1. So what will be the order of Jacobian matrix having these 4 elements J11, J12, J21 and J22? We can observe from here, number of rows in J11 is n minus 1, number of rows in J21 is m minus 1. So total number of rows will be equal to n minus 1 plus m minus 1, that is n plus m minus 2. So we may write the order of Jacobian matrix as n plus m minus 2 number of rows by number of columns. So number of columns here is n minus 1, n minus 1, here m minus 1. Again sum of these will be n minus 1 cross m minus 1. So we may write n plus m minus 2. This is the order of Jacobian matrix. This way we have evaluated all the elements required for the calculation using Newton-Raphson method of load flow. Additionally, for PV buses we have to check the calculated value of Q and compare it with the limiting values. So first write, for Rth iteration we may write, for Rth iteration we will write Q for ith bus. Say for Rth iteration let us denote by QIR. So what is the formula of Qi? Minus Vi summation k is equal to 1 to n, where n is number of buses, Yik Vk for Q sin of theta ik plus delta k minus delta I. So here identify the variables. So variables are V and delta. Yik, theta ik are constant quantities corresponding to the Y bus matrix. So only at each iteration the unknowns will be updated. So for Rth iteration you need to calculate, you have delta Kr, delta Ir and Vkr. Why not VIR? So why not VIR? Question is, we are going to calculate Q for PV buses, and for PV buses, for ith bus Vi is specified quantities. We are not going to calculate the specified quantities. Only those quantities which are not specified are required to be calculated. So here Vi will be the specified quantities for ith bus, for which we are going to calculate Q, that is QIR. So what is the next task which we have already seen during Gauss-Seidel method of load flow? We need to compare this Qi calculated with the limiting value. Suppose if Qi lies between Qi mean, QIR lies between Qi mean and Qi max. The limiting values of Q for ith bus, okay, that's fine. It is lesser than Qi mean or more than Qi max. In that case, that particular PV bus will be treated as PQ bus, and the remaining calculations will be corresponding to PQ bus. So otherwise, or we can write else. Else means either below this or more than this, that bus will be treated as, we may write PQ bus, and we need to calculate VIR. That will be equal to, again, the previous iteration value, VIR minus 1 plus delta VIR minus 1. Fine. Any doubt here? So next we will summarize the things in the form of steps. So our next heading will be steps for Newton-Raphson method of fluid flow. Now we will write the various steps for Newton-Raphson method of load flow. So first write step number 1, read system data. Step number 1, read system data. Step number 2, formulate Y bus. Formulate Y bus. Step number 3, assume initial values. So first 3 steps are similar to that of Gauss-Seidel method of load flow. We know we need to read the system data, R, X values, etc., etc., and we can formulate Y bus. The main task is assume initial values. So we need to assume the values corresponding to variables, because we don't know the values of variables. So first task is to assume the initial guess values. So for PQ buses, unknowns are V and delta. So assume VI0 and delta I0 for PQ buses, because V and delta are unknown for PQ buses. Next, for PV buses, unknowns are Q and delta. So Q will be calculated as Q is itself function of V and delta. So only we need to assume delta I for PV buses. Fine. Next we need to calculate, focus here, del P, and we know del P is difference of specified quantities and calculated quantities. So we know specified quantities. First write calculate what? For PQ we are having P and Q both as specified quantities. So we will calculate Pi and Qi for PQ buses, because these two quantities are specified, hence Pi and Qi are required to be calculated, so that we can take the difference between specified quantities and calculated quantities, so that del P and del Q corresponding to PQ buses will be obtained. So what about for PV buses? So for PV buses we are having P and V as specified quantities. So only Pi is required, Pi for PV buses. Next we will write here itself again fourth, after fourth write fifth, calculate del P and del Q. So corresponding to Pi and Qi, del Pi and del Qi for PQ buses and del Pi for PV buses. Fine. Recall the formula of del Pi. Del Pi is nothing but can be calculated as Pi specified minus Pi calculated, right? Similarly, del Qi will be Qi specified minus Qi calculated. So we have calculated del P and del Q. Next task will be to calculate the elements of Jacobian matrix. So next we may write 6 formulate Jacobian matrix. We have discussed in detail how to evaluate the elements of Jacobian matrix, you know it. So after that we have evaluated this del P del Q, we have evaluated this. So next we will evaluate this using this relation. This matrix will be nothing but send this matrix to this side. So inverse of this times this matrix we can evaluate. So directly write here evaluate we may write del delta del V matrix, this one. So once correction matrix are, we will update the corresponding values. So after this write the next step, step number 8 right here, 8, step number 8, update, right here update. So update, what will be updated here? Unknowns, the values which we have initially assumed will now be updated. So for PQ buses unknowns are delta I and Vi, and for PV buses unknowns are delta I. So how these unknowns will be updated? We may update, we know del delta suppose 0, initial value delta 0, suppose delta I plus del delta I will be equal to delta I1, updated one from assumed value to iteration number 1. So this will continue. Suppose for rth iteration we may write delta IR is equal to delta I R minus 1 plus del delta I R minus 1, previous iteration value and calculated corrections. So this will give update the delta I. Similarly for Vi also we may write VIR is equal to VI R minus 1 previous iteration value plus correction calculated R minus 1. This way we have updated. For PV buses the next step right here directly, step number 9, calculate QI R for PV buses. So we have QIR may be calculated this way. So QIR will be calculated only for PV buses, and it will be checked with the limiting values whether it lies between the QI min and QI max. It's okay, it will be PV bus, no issue. So return to the step number 4, right? So return to the step number 4 for the next iteration. Otherwise, else that particular PV bus will be now treated as PQ bus, and again this will be calculated, and QI will be updated with the limiting value. If it is below QI min, then QI will be equal to QI min. If it is more than QI max, then QI will be equal to QI max, and again return to the step number 4 for the next iteration, and this way iterations will be continued unless we have reached the stopping criteria. So what will be a stopping criteria? You can check the values of del Pi and del Qi. If maximum of del Pi and del Qi means del Pi corresponding to all PQ and PV buses, or del Qi corresponding to all PQ buses only. If maximum of these del values are within tolerance, equal or less than certain pre-specified value tolerance, then we will stop here. So this way we can apply Newton-Raphson method of load flow. Further, with the help of a simple example, we will see all the steps after this. So now we will solve a simple 3-bus problem. First bus number 1 is slack bus, and bus number 2 is PQ bus, bus number 3 is PV bus. So for this simple 3-bus system, we are having first one slack bus and the other 2 buses, the 2 PQ type and PV type buses are here. Problem statement is, for the system shown in the figure, the 3 lines have a series impedance of 0.02 plus j times 0.08 per unit, and a total shunt admittance of j 0.02 per unit. In other words, we can say that all the 3 lines are identical in all respect, having the same series impedance as well as shunt admittance values. Now the objective is to evaluate, find the values of V2, delta 2, Q3 and delta 3 at the end of first iteration of Newton-Raphson method of load flow. V2 and delta 2, see bus number 2 is PQ bus, obviously unknowns are V and delta, that is why it has been asked to evaluate V2 and delta 2. Bus number 3 is PV bus, so unknowns are Q3 and delta 3. So all the 4 unknowns corresponding to 2 buses, bus number 2 PQ bus, bus number 3 PV bus, we have to calculate. So we will apply the same steps which we have covered before that. So we can evaluate Y series as all the 3 lines are identical. So Y series. Next we will evaluate Y series as all the 3 lines are identical. So Y, that is admittance, will be 1 upon impedance, which is given 0.02 plus j times 0.08 per unit. So it is coming out to be this in rectangular form, or in polar form we can get this. Similarly, each of diagonal elements of Y bus, of diagonal elements are nothing but negative sign Y values. So whatever we got for all the lines, we will get negative of that. In polar form, we will get this one 12.13, 104.04 degree. And each diagonal elements of Y bus, so diagonal elements are this self admittance times, see it's given shunt admittance as 0.02. So assuming nominal pi model, that 0.02 will be divided into two parts, one from here, one here. So this will be 0.01, half of 0.02 and 0.01 here. So for self we will get 0.01 here and this series, 0.01 here and this series. So twice of this value, the same 2.941, this one minus j 11 point this y series, and half of the 0.02. So twice of this. In rectangular form we will get this, or in polar form we will get this one. So this way we have formulated our y bus where all diagonal elements are this and off diagonal elements are this. Now assume initial value. Step number 3, assume initial value for unknowns. So unknowns are V2, delta 2, delta 3. We will not assume any initial value for q because q is itself a function of v and delta. So just we need to assume V2. So generally we assume 1 per unit, and initially delta values are assumed to be 0. So assume delta 2 0, delta 3 0. 0 indicates initial values equal to 0. Recall the formulas for Pi and Qi. Formula for Pi is this and Qi is this. Using this formula, general formula, we may write P2 as this V2 k is equal to 1 to n number of bus 3 here, y2k vk cos of theta 2k plus delta k minus delta 2, I is 2, P2. Similarly, for I is equal to 3, P3 we will get this one, and for I is equal to 2 in this equation Qi we will get Q2 is equal to this. Substituting given and assumed values of different quantities, we may calculate P2 0, P3 0 and Q2 0. Means initial values, initial calculated values of P2, P3 and Q2. So we will get this one. This way we have calculated this. So after calculating P2 0, P3 0, Q2 0, we will calculate del P and del Q values. So corresponding to P2 0, we will get del P2 0, that is difference of P2 specified, that is 0.05. See here, P2 specified is 0.05 minus calculated value of P2 0, that is minus 0.23 per unit. So difference will be this one. This is del P0 0, del P2 0. Similarly, we will evaluate del P3 0 and del Q2 0. We have for this 3 bus system del P2, del P3, del Q2 Jacobian matrix times del delta 2, del delta 3, del V2. First we need to calculate the elements of Jacobian matrix. We know how to calculate J11, right? So this will be corresponding to, first from here, first we know it. So using the same procedure we will evaluate J0, initial value of the Jacobian matrix as this. Once we have evaluated this, the next task is to get the values of corrections, that is del delta 2 0, del delta 3 0 and del V2 0. So now using this relation we have the Jacobian matrix ready with us. So these corrections, these initial values will be updated, or we can say calculated by taking inverse of the Jacobian matrix, which is J0, inverse of this times del P2 0, del P3 0, del Q2 0. Here we are having del P2 0, del P3 0 and del Q2 0. After substituting the corresponding values, we will get del delta 2 0, del delta 3 0, del V2 0, that is corrections as this one. So once these corrections are added to the initial assumed values, we will get the updated values of the variables. So this way the updated values of the variables will be equal to this initial values plus this correction values evaluated. So now we have updated our initial guess values as this one. So this way we have calculated delta 2, delta 3 and V2 at the end of first iteration of Newton-Raphson method of load flow. So the fourth one, Q3 that is one for first iteration that is asked. So using the updated values, we know the equation of Q3, we know Q3 Qi minus Vi, k is equal to 1 to n y I k V k sin of theta I k plus delta k minus delta I. So using that, substitute I is equal to 3 and the updated values of variables and other parameters, we will get Q3 as 0.4677 per unit. These values are also in per unit. Thank you very much.